Hey folks, it's Steve here. Let's talk about the different types of programming languages. Programming languages, they're like the bizarre, ever-expanding family of tools we use to tell computers what to do. Each one has its own quirks, strengths, and weaknesses. Some are elegant and sophisticated, like a Swiss Army knife, offering a multitude of features and capabilities. Others, well, let's just say they're more like that rusty spork you found in the back of the drawer. Functional, but not exactly your first choice. But hey, sometimes you just need to open a can of beans, right? And in those moments, even the rusty spork has its place. Just like you wouldn't use a hammer to fix a leaky faucet, you wouldn't use JavaScript to write an operating system. Well, you could, but it would be like trying to herd cats. It's technically possible, but not advisable. Different tasks require different tools, and the world of programming languages offers a diverse toolbox to choose from. From Python's simplicity to C++ power, there's something for every need. So buckle up, Buttercup, because we're about to take a whirlwind tour through the weird and wonderful world of programming paradigms. We'll dive into object-oriented, functional, and procedural programming, among others. We'll explore the strengths and weaknesses of each, and hopefully, by the end, you'll have a better idea of which language is right for your next coding adventure. Whether you're building a website, developing a game, or analyzing data, there's a language out there for you. And who knows, you might even have a laugh or two along the way. After all, programming is as much about creativity and problem solving as it is about logic and syntax. First up, let's talk about object-oriented programming, or OOP for short. It's a fundamental concept in software development that helps you structure your code in a more manageable and scalable way. Imagine your code is a zoo, a bustling place filled with various creatures, each with its own role and purpose. You've got lions, tigers, and bears, oh my, each with their own unique characteristics and behaviors. Just like in a zoo, each piece of your code has its own specific function. OOP lets you organize these animals into neat little enclosures or objects, making it easier to manage the chaos. These objects act like containers that hold both data and functions. Each object contains both data, like the animal's name, age, and species, and methods, like eat, sleep, and roar. This encapsulation ensures that each object operates independently. This encapsulation helps keep things tidy and prevents your code from turning into a tangled mess of spaghetti logic. It makes your code more modular and easier to debug. OOP also promotes code reusability through inheritance. This means you can create new objects that inherit properties and methods from existing ones. Think of it like this. A lion is a type of cat, so it inherits all the basic cat-like properties and behaviors. This allows you to build complex systems more efficiently. This means you don't have to rewrite the code for meow every time you create a new feline object. You can simply extend the existing cat class and add specific features for the lion. However, OOP isn't without its drawbacks. It can sometimes make your code base more complex than necessary. It can be a bit verbose, requiring you to write a lot of boilerplate code. This can be time-consuming and may lead to errors if not managed properly. And let's be honest, sometimes all those objects and classes can feel a bit like overkill, especially for smaller projects. In such cases, simpler paradigms might be more effective. Next, we have functional programming, the minimalist's approach to coding. It's a paradigm that emphasizes simplicity and clarity. If OOP is a bustling city with its complexity and constant activity, functional programming is a serene monastery offering peace and order. It's all about writing concise, reusable code that's easy to test and debug. This approach minimizes errors and makes your codebase more maintainable. The core principle of functional programming is to avoid side effects. This means functions should not alter any state or interact with the outside world. A side effect is anything that changes the state of a program outside of its immediate scope. This can lead to unpredictable behavior and bugs. Think of it like this. A pure function is like a vending machine. It consistently delivers the same output for the same input. You put in your money, select your snack, and out it pops. The process is predictable and reliable. The machine doesn't suddenly start dispensing potato chips instead of candy bars because you sneezed on it. It operates without unexpected side effects. Functional programming languages like Haskell and Lisp are known for their elegance and expressiveness. They allow you to write clear and concise code. They're great for tasks that involve data manipulation, concurrency, and parallel processing. These languages excel in handling complex data transformations. However, functional programming can be a bit of a mind-bender at first, especially if you're used to imperative programming styles. It requires a shift in thinking. It requires a different way of thinking about problem solving. You need to break down problems into smaller, purer functions. Plus, let's be honest, sometimes you just need to mutate some state, and functional programming can make that feel like trying to solve a Rubik's Cube blindfolded. But with practice, it becomes more intuitive. Now let's talk about dynamic programming languages, the free spirits of the coding world. Languages like Python, Ruby, and JavaScript fall into this category. They're known for their flexibility, rapid prototyping capabilities, and forgiving syntax. In dynamic programming, you don't need to declare variable types explicitly. The interpreter figures it out at runtime. This makes for faster development times and less boilerplate code. Plus, these languages often come with vast libraries and frameworks, making them incredibly versatile. However, this flexibility comes at a price. Dynamic typing can lead to unexpected runtime errors if you're not careful. And let's be honest, debugging those errors can feel like trying to find a needle in a haystack the size of Texas. Section 5. Declarative programming. Telling the computer what to do, not how to do it. Finally, we have declarative programming, the Zen master of programming paradigms. SQL and Prolog are prime examples of this approach. In declarative programming, you focus on describing the desired outcome, not the step-by-step instructions to achieve it. It's like telling your friend to make me a sandwich instead of giving them a detailed recipe with precise measurements and cooking times. You trust them to figure out the how while you relax and enjoy the results. Declarative programming is incredibly powerful for tasks like database querying and artificial intelligence. However, it can be challenging to wrap your head around at first. Plus, it's not always the most efficient approach for every problem. Section 6. Choosing the right language for the job. A practical guide. So, with all these different programming paradigms to choose from, how do you know which one is right for your next project? Well, there's no one-size-fits-all answer. It depends on a variety of factors, including the project's requirements, your team's expertise, and your personal preferences. If you're building a large, complex application that requires a high degree of organization and code reusability, OOP might be a good choice. If you need to process large data sets quickly and efficiently, functional programming could be the way to go. For rapid prototyping and web development, dynamic programming languages are hard to beat. And for tasks like database querying in AI, declarative programming might be the perfect fit. Section 7. Beyond the Big Four. A glimpse into other programming paradigms. Of course, the world of programming paradigms doesn't end with OP, functional programming, dynamic programming, and declarative programming. There's a whole universe of esoteric and experimental languages out there, each with its own unique quirks and philosophies. There's logic programming, where you write code as a set of logical statements, and the computer uses deduction to find solutions. There's aspect-oriented programming, which aims to separate cross-cutting concerns from the main program logic. And then there's esoteric programming, which is basically the Wild West of programming languages, where anything goes. Section 8. The future of programming languages. What's next? As technology continues to evolve at a breakneck pace, so too will the languages we use to interact with it. We can expect to see new paradigms emerge, existing ones evolve, and perhaps even some mind-bending hybrids that defy categorization. One thing's for sure, the future of programming is going to be anything but boring. Section 9. Conclusion. Embrace the chaos and keep coding. So, there you have it. a whirlwind tour through the fascinating and often bewildering world of programming languages. Hopefully, you've learned a thing or two, had a few laughs, and maybe even been inspired to try out a new language or paradigm. The most important thing is to remember that there's no right or wrong way to code, well, except for maybe using go-to statements. The best language for the job is the one that gets the job done effectively and efficiently. So, embrace the chaos, experiment, and most importantly, keep coding. If you enjoyed this video, don't forget to like, subscribe, and share it with your fellow coders. Happy coding!